We want to use the integral test to determine if the following infinite series converges or diverges. So the first step, we want to find a function f of x such that f of x is positive, decreasing, and continuous on the interval from, in our case, 2 to infinity, since n starts at 2, such that f of n equals a sub n. Then, if this improper integral, in our case from 2 to infinity, converges, then the infinite series converges, and if this improper integral from 2 to infinity diverges, then so does the infinite series. Looking at the formula for a sub n, notice how we would let f of x be equal to 1 divided by the quantity 4x plus 3 raised to the fifth. Notice f of n would equal a sub n. This function is also positive, continuous, and decreasing on the interval from 2 to infinity. So now we want to find the integral, again from 2 to infinity, of f of x integrated with respect to x, and determine if this converges or diverges. Let's rewrite this as the integral from 2 to infinity of, let's move this up to the numerator, which would change the sign of the exponent. This would be the quantity 4x plus 3 raised to the negative fifth. We have an improper integral, so we'll write this as a limit. We'll have the limit as b approaches infinity of the integral from 2 to b of the quantity 4x plus 3 to the negative fifth integrated with respect to x. We'll be applying this integration formula here. Notice how we do have to perform u substitution, where u would be equal to 4x plus 3. Therefore, differential u equals 4 dx. So if we divide both sides by 4, notice that 1/4 du equals dx. So when integrating this, we'll have an extra factor of 1/4. And if it's helpful, we can write this in terms of u. We'd have the integral of u to the negative fifth, and again, dx equals 1/4 du. We may be able to perform mental u substitution, but if not, this can be helpful. So now we'd have the limit as b approaches infinity of, the antiderivative would be 1/4 times u to the power of negative 5 plus 1, which is negative 4, divided by negative 4, or in our case, we'd have 1/4 times the quantity 4x plus 3 to the negative 4 divided by negative 4, or times negative 1/4. And the interval is from 2 to b. Notice here we have negative 1/16. Let's go ahead and factor that out. We have negative 1/16 times the limit as b approaches infinity of, let's rewrite this back in fraction form. We'll write this as 1 divided by the quantity 4x plus 3 raised to the fourth. In this form, it should be easier to determine the limit. So we have negative 1/16 times the limit as b approaches infinity of, well, when x is b, we'd have 1 divided by the quantity 4b plus 3 to the fourth. And when x is 2, we have minus 1 over, we'd have 4 times 2, that's 8, plus 3 is 11. We'd have 11 to the fourth. Well, as b approaches positive infinity, notice for this fraction, the denominator increases without bound, and therefore this approaches 0. And notice this fraction is not affected by b, and therefore we'd have negative 1/16 times, this would be negative 1 over 11 to the fourth, which would give us positive 1 over 16 times 11 to the fourth, which comes out to 1 divided by 234,256. Looks like our fraction is correct. But the main thing to point out here is that because we have a finite value, this improper integral converges, and therefore so does the infinite series. So now let's summarize our work. We'll say the integral from 2 to infinity of f of x, which is 1 divided by the quantity 4x plus 3 raised to the fifth, integrated with respect to x, converges as we've just shown. So, by the integral test, our infinite series also converges. I hope you found this helpful.